Hello and welcome to another episode of our Let's Talk Climate Change series. It's a particular personal privilege for me to have Professor Diwakar here. Professor Diwakar is ISRO Chair Professor at NIAS, the National Institute of Advanced Studies, and also the person who taught me remote sensing close to 30 years ago, I think 1993. So just a little bit of background for people. Digital remote sensing, satellite images were there in the country, but they were mostly being manually looked at, and digital remote sensing had just come in. My advisor, then my PhD advisor, Professor Madhav Gadgil, had access to a lot of images of the Western Ghats, and we said, what do we do? And we landed up at the Regional Remote Sensing Service Center, where Professor Diwakar was then, and he landed up teaching me remote sensing. So I think I have a lot to thank you for starting me on the sustainability journey. It's a real pleasure to have you here. And I was wondering, when did you start working? Were you always working with satellite imagery, or when you joined ISRO, what was your educational background before that?
Okay, I joined ISRO in 1984. Before that, of course, I did my post-graduation in mathematics and statistics.
Mathematics and statistics?
Statistics.
Where?
In Bangalore University.
Okay.
Before that, I was in Indian Institute of Management. I was pretty good at programming, so I used to spend a lot of time in Institute of Science solving a lot of problems on DEC 1090 systems those days.
Right.
So
our early versions of supercomputers.
Yeah, that's right. So started my career in computation using punch cards and things like that those days. So maybe our generation is the only generation which has seen end to end of computing.
Punch cards to AI.
Yeah, punch cards to AI and possibly even
something more.
High power computing even today. So computing doesn't leave me anyway. So the career started off like that. So I was not having any intention to join ISRO as such, but
you must have been unusual as someone who knew computers but also maths and statistics, because usually they are different domains, but they are actually important for each other, but no one teaches them together.
Correct, exactly. I should really appreciate this Bangalore University Department of Statistics, which had a good balance of maths and stats, and also there was a special paper on computer programming. So we were taught Fortran programming, Pascal and COBOL. These were the three programming languages taught, and to a large extent I used to write Pascal programming, and Pascal is pretty close to C. Subsequently we got into C and C# and C++, etc. So that's how I was into this, and the beauty is when in 84 I joined ISRO, as you rightly said, there were no big digital systems.
How did you come to join ISRO?
That is also a sort of a chance only, but somewhere in the back of my mind I was interested in rockets. So I used to talk, I used to read a lot about rockets, and I used to explain them to my friends in the class and all, how the rockets work, etc. Mostly I used to follow the Apollo programs. So that was somewhere in the back of the mind, and whenever we come to Bangalore University, before our bus, there used to be an ISRO bus passing by. So I used to look at that ISRO bus and see how beautiful they are. They will be working on space and related things. So somewhere it used to be there in the back of the mind possibly. And luckily or unluckily, one fine day, I just came back. I used to work in IIM. I was assisting one professor in graphic programming. So my dad said there is an interesting possibility of a job. So why don't you apply? I said, I don't want to apply. It's boring. I'm very good at IIM. I will continue my career at IIM. That's what I told him. But in my name, he has applied. And I got an interview call one fine day for a scientific assistant post. So he insisted that I should go. Around that time, I had already given interviews in Wipro and many other professional industry, this thing, and more or less I was selected also. But somehow this ISRO interview I was caught up in that sort of. My dad pushed me there. So it was a tough interview, no doubt, because ISRO interviews are not easy. Pretty tough. There were 12 people firing left and right questions to you. The blackboard was full by the end of my interview. So many things were asked. And I got selected also. So now the problem was to join Wipro or ISRO or another two organizations. So I was pushed into ISRO finally. That's how I got into ISRO.
That's how you got into ISRO. It's reminding me of when I finished my BSc, I was the first batch of integrated PhD biology in Indian Institute of Science.
Correct.
I would not have joined if my father hadn't pushed me, because I was hell-bent. The day of I wrote the exam without any expectation I'll be called for the interview. And when I was called for the interview, I said they will select 3 to 6 people across the country. Of course, I will not get in. So I decided there was some obscure college in Hyderabad, I don't even remember the name now, which I was hell-bent on going there. And my father insisted that you can't go for that entrance exam, which I was very sure I would get into, because it clashes with the ISC interview.
Oh, okay.
So he pushed me into the interview and I got it.
Almost similar.
Thank goodness for fathers,
So
I think.
good parents. They have pushed you into the right
Yes,
places.
Exactly.
I think we should remember.
Yes, absolutely. So then you joined ISRO?
I joined ISRO in 1984. I was in National Natural Resources Management System.
Right.
It was a system which had just evolved. 1983, Dr. Satish Dhawan had, Professor Satish Dhawan really gave that idea that NNRMS should be a virtual body working with all the ministries of Government of India, so that in future we will be able to utilize remote sensing. I think that's a beautiful forethought.
Can you tell people what the NNRMS is? Because it was unique. I don't think many countries had this kind of a
I don't
system.
think so. In fact, many countries used to come and ask me how this NNRMS is, how does it function, how did it come into existence, and things like that. Actually, the architecture was very good. The whole thing was virtually done by ISRO. ISRO was basically a body which will operate this NNRMS, but it was a virtual body. And some of us were recruited to do that particular job. But at the same time, different ministries were linked to it. For example, Agriculture Ministry, Forestry, Geology, Meteorology, like that. There were about 9 key ministries which deal with natural resources management in the country. They were sort of linked into this, and the secretary of the respective ministry was the chair of a standing committee. So they made 9 standing committees. Each of these standing committees will have the chair will be by the secretary, and member secretary will be drawn from ISRO
So
for all the ministries. Okay. So we will be operating all of these. So the beauty of this system is the respective ministry will come out with their problems. They will pose those problems in the standing committee, and from ISRO side, on the remote sensing side, or from communication side, or from GNSS, we are supposed to tell whether the problem can be solved from space.
So can you give a couple of examples? Let's say in agriculture, what were the problems? And in forestry, what would be the problems?
I will tell you. For example, agriculture, the beginning was like government was interested in understanding how much amount of wheat are we going to grow in this Kharif. How much of rice are we going to grow in this
Very
Kharif?
Important question for India's food security,
Yeah,
especially
exactly.
there.
Exactly right. It had started from there itself. In fact, today in my talk, I'll be addressing quite a few of those. So, Kharif, Rabi and Summer, 3 seasons. So, season-wise, is it possible that you can use remote sensing and tell us how much amount of rice, paddy, or oil seeds, or sorghum, and many of these important crops, major crops, how much it is going, in the sense, not only area of production, but also yield. Is
and
it possible?
Indian remote sensing satellites, I think they were again very unique. There was, at that time, the French satellite, the American satellite, the
French and American was there. Landsat series was there. Brazil was not there. Only Landsat was there, and Spot came into existence a bit later.
And the Indian remote sensing. So
Indian remote sensing satellite came at 1988, 4 years later.
4 years later.
But we had already prepared ourselves with Landsat. So we were ready for it.
So you knew how to process the data and what you needed for an IRS, Indian remote sensing satellite.
In fact, initial days were pretty tough because good thing about what I learned in the college straight away came into play when I started doing image processing, because digital image processing is full of
maths and statistics.
Maths and stats, and I became a master there because everybody used to be around me, because most of those algorithms I used to program and solve the problems back there.
Matrix algebra, Bayesian statistics,
exactly.
You know a few of those things.
Yeah, that's right. So,
I ran away from maths and statistics in my BSc, and I thought I was escaped it in my MSc, which is molecular biology, and I came back to remote sensing, and I had to teach myself everything. So I know, but you would have had a huge...
Actually what happened is we didn't have a good image processing system at all. The very first IBM PC XT came into India directly to our office. So I started working on my algorithms on a IBM PC XT. And I used to link myself to a Sperry UNIVAC system sitting in ISAC. 10 kilometers away. So I had connected it by telephone cable, and I used to implement my algorithm on that and see the display on my PCXT. That's how I started my image processing. But down the line, ISRO tied up with a French group. There was a SEP. It's basically before CNES, SEP was there. SEP basically was making some very good image processing software, but that used to run on VAX 11780. So we were about 5 people selected to go and get trained there. So we all went to France to get trained on this. But before that, we did a lot of training here. There was a small system working at Anna University, Chennai. So we were sent there, we got some training there, came back and then went there. But in a very short time, we became masters. We started teaching them what it is because our algorithms were so comfortable with us. And 1988, we were supposed to be launching our satellite, and we were supposed to be working for data processing of those satellite data much in advance. So 1986-87, we were working on that system.
How much input did you give on the design of the satellite itself? Like, these are the frequencies, these are the band wavelengths, this is the kind of data they should collect.
Actually, this was already done. Actually, I got involved a bit later when we got into shortwave middle infrared band for IRS. But before that itself, at Space Application Center, Ahmedabad, Dr. Navalgund and his team had already decided on what kind of spectral bands are required for us to do imaging because of the experience from Landsat.
So that conversation is very critical.
Yes.
Because I remember, again, when I started first, I remember I went to Aranya Bhavan to look at some data and understand how they did visual image processing. And there was a person who had been working there for 20 years on some visual processing last 5 years. But before that, otherwise, these images, the stereo images.
Correct.
And he told me that it's not good for you to be doing a PhD on digital remote sensing. People like you will come and take away our jobs because you can automate things, and you need 20 of us, and now 2 of you will be fine.
Correct.
And I keep thinking of him when I think of the AI issues. So
okay.
But did you feel that digital remote sensing actually took away jobs, or that added a different way of thinking?
In fact, the problems also increased, right? So if we had not moved into digital image processing, we couldn't have solved many of the problems. See, today, more or less, literally, we have created databases on all natural resources in the country, and respective ministries and even state remote sensing centers are able to use it for the respective state governments. This couldn't have happened if we had not moved into the digital domain. So it didn't. I don't think it took off jobs. It added a lot of jobs.
It added.
And see, we moved into even geospatial technology. We got into GIS. So all the image data processed got imported into GIS. Then layer stacking and multi-layer modeling.
Exactly.
So many things have happened. So
Absolutely.
that way it has added.
It has added
a lot of opportunities for youngsters and innovations also, particularly for modelers. So
I remember when I met you first, which is around 93, 94, and we had come with those 52 images. You were then in the Regional Remote Sensing Service Center.
That time we had brought the VAX 11780. After training at France, we had got it to Bangalore. We got 5 systems in five parts of the country. We installed them, and I was leading in Bangalore.
Oh, that's the time.
That's the time I met you.
Correct.
Yes.
So then because I was getting trained at the same time, I think that was the time you were doing the planning for the Bangalore Ring Road.
Correct.
So
that was going on.
The Ring Road and the peripheral Ring Road came because ISRO was doing the planning.
Yes. We did the alignment of the Ring Road and gave the entire plan to the government. And we used the satellite data in a very, very nice way. Those days we didn't have very high resolution satellite data, but CNES spot 10 meter resolution was the best available. So we used that data. For overall, synoptic view, we used our satellite data, but when we got into 10 meter resolution processing, we used spot data. And we made the alignment and gave it to them. Yes.
And were you doing this in other cities across the country?
See, this know-how was passed on to the other regional centers. So respective regional centers started working with, let us say, it could be Mumbai or Delhi, it could be something in Lucknow and things like that. So we had centers all around the country. So all these centers parallelly started working. Again, this was the brainchild of Professor Satish Dhawan, who thought remote sensing should be like a pyramid, like National Remote Sensing Center will be at the national level, Regional Remote Sensing Center will address the 5 regions, and then you have to have the State Remote Sensing Center. It's part of NNRMS again. It's the brainchild from NNRMS to this. So how the data processing has to happen was also thought much in advance, which became very meaningful and useful for the entire country. In fact, it's a very unique model for the country.
Absolutely. That's why I was wondering. I remember now also lots of people from different countries. So there was a contingent from an African set of countries which had come, and I was there who was trying to learn how to use the software.
Correct.
So from Regional Remote Sensing Center, where did you move after that?
From Regional Center, I went off to Dehradun for some time because they wanted me there. That was one of the center which had more expertise in remote sensing, so they wanted my help there. So I was there about 3 years, and in between they wanted me to go to Mauritius and set up a remote sensing center there also. I set up a national remote sensing center at Mauritius and came back. And then I was in Bangalore for some time. Then I was shuttling between ISRO headquarters and Bangalore for different jobs. And finally I went off to Hyderabad at National Remote Sensing Center as Deputy Director, taking care of all applications of remote sensing, and then finally moved back to ISRO headquarters as Scientific Secretary.
That's right, correct.
Possibly one of the best top level position at ISRO, so that you get to see the overall ISRO related activities.
What surprises, I think, not surprises, what impresses everybody about ISRO is the level to which there are good people and they work together to get things done. The team effort is incredible.
Always team effort. In fact, no individual stands out in any project. We put our heads together. Of course, there's a project leader, there's a deputy project leader, the hierarchy exists, but everybody works together, including the leader. So what do
you think is the secret of that success? That everybody gives their best, 300%, 1000%?
No doubt.
And
there's
without
no day
egos,
or night.
Without egos.
Yeah, no egos.
So how does that culture work? Because it's so difficult to build a positive culture and it's so easy to break it.
Correct. I think I would again give credit to our great fathers. I would say like Dr. Sarabhai and Satish Dhawan, Professor Abdul Kalam, and people like them. They have been sort of Professor Yuvar Rao, Dr. Kasturi Rangan. They have all worked like that, lived like that. So automatically you will follow them. No, like our parents, when you are around your parents, you will follow them.
Right.
And they are like parents only for us. In fact, they have changed our lifestyle, I would say. Even at home, we are different. We are not like others, I would say. Many of the ISRO families, they are very systematic, very orderly, and do things in a, what do you call, end-to-end manner. And most of the things you do it yourself at home. See to that it is perfect. Like that it is.
Like that.
Because that's how we are brought up in ISRO. Correct. So we do the same.
You can't be systematic at the workplace or unsystematic
exactly.
at home.
So it became part of our life. And that is really something very interesting. And it's always teamwork, as you rightly said.
And it's also innovative. Often again, technology gets stuck at a certain level and there's no innovation beyond. But every time there's something new that is being brought, new products, new ways of thinking.
Correct. And we don't hesitate to call something wrong when it is wrong. Even if you are talking to a senior, even if you are telling something to the chairman, and chairman ISRO encourages such things. Many times I remember myself saying that, sir, this is not the way. This may not work. This will give us wrong result. These kind of things have been told, and that is taken very seriously. And it will be cross-checked, revalidated. That is the beauty of ISRO teamwork, wherein criticizing also is taken positively and it is addressed, corrected, taken forward.
It's very nice. It's a very different work ethic.
Yes.
So from there, when you retired, and what made you think of moving then completely into academia? I remember that it was always an interest of yours. You always wanted to find time for research.
Right. Actually, see, Sivan was the chairman of ISRO. So 2018, I retired actually. So Sivan told, no, Diwakar, how can you have to be there. I said, sir, I have something else to do in my life. I want to do, I've been waiting for that. I will do. What do you want to do? I told, I want to do agriculture myself. I want to grow. In fact, I have a farm. I do agriculture in weekends.
Where?
I'm a farmer actually now.
Where?
It's slightly beyond Attibele. Slightly beyond Attibele.
Wonderful. Okay.
So he told, no, that you do later, but you be with me for some more time. So he got me 2 more year extension. So I continued up to 2020. At 2020, I told, sir, I have to go. He said, how can you go? You have to be here again. I told, no, sir, I have to go. So finally, he said, okay, fine. Then I left. And somehow Dr. Shailesh Nayak came to know that I am leaving. So he told, you are not going anywhere, you are coming here. So he pushed me into NIAS. So I got in there. So thanks to my family, they supported me. They said, okay, go ahead. Otherwise, it wouldn't be possible. Because most of the time in my ISRO life, I've hardly spent time with my family. I thought this is a good time, but so far it has not happened. I continue at NIAS the same way.
But
that's how it goes.
You now have a grandchild,
I have
granddaughter,
I have a
grandson.
grandson. Yes.
And you've seen so many changes in the world's planet, climate, environment, all of those things. But also much hope, because many young people, as you would see in NIAS also, and we see at Azim University, some of these young people are doing tremendous things that we would not have thought of possible at our age. So what gives you the greatest worry for your grandchild's generation, and what gives you the greatest hope, optimism?
Worries are there because the kind of world we are leaving behind for the younger generation is not the same good one what we enjoyed. We possibly, compared to what we are today with respect to the kind of ecosystem, the environment, it was much better. Let us say I am 65 now, so let us say by last 50 years if I take, things were much different, much better. We have spoiled, polluted, everything we have done. And I only hope that we work positively from now on, and then see to that we retard this process, which is not easy, which is pretty tough. And I have a lot of hope in the present younger generation who are innovative, brilliant, and they will certainly find a better way out to find solutions for the kind of problems what we are facing. It could be pollution in the air, pollution in the water, it could be a lot of food related problems, and all kinds of problems could be there, but there should be a way. Even we don't stop, we continue to innovate and see to that we build a better future. And I'm sure the future generation, I still hope that they will get a good life. And today, the another interesting dimension to the space is that we are exploring exoplanets, we are exploring other planets. I do hope that we'll find a beautiful planet where many of the people will be able to migrate and lead a happy life there also.
That's an interesting one. I hadn't thought of that.
Yes. A lot of findings even today on Mars.
Exactly.
And there are hopes in Moon also, on human habitation. So we hope something good will happen both in Moon and Mars.
Okay.
Why not? And some of the moons of Jupiter is also having a lot of promise.
That's very interesting.
Yes.
But so I also see a lot of climate startups, and I think ISRO has been working with many of them to nurture an ecosystem through NIAS, and many of you, Professor, so many other people have been working. And what kind of things, if you are a young person now entering the climate space, what would be the advice for where should you look for jobs? In the ISRO or government setups, in the climate setup, what is the range spectrum of possibilities, and what should they be doing?
See, climate, if you have to really pursue your career in climate, first step for anybody is to understand the multifarious phenomena of the nature. Because we have worked a lot in GIS and we have understood the natural resources to some extent. I wouldn't say that we have understood perfectly, because the variability is so high, it is so diverse. But I feel equipping oneself with technology becomes very, very important for anybody. Before you enter into, entering into a startup or entering into ISRO kind of a organization or any other organization which does top quality research is not a problem. You can, but without equipping yourself with the capabilities, you can't dream of going into such kind of this thing. So if you have to really equip yourself, you have to do a lot of work. So what is the kind of work? You have to do a lot of hard work on data collection, data organization, data processing, and see what kind of results you get. In the sense, you have to really muddy your hand by getting into hardcore data processing, modeling, getting into mathematics of it. Because the kind of impacts the climate would have on local area as compared to a regional scale or compared to a larger scale is different. So today we are seeing in India itself the kind of local problems we are able to face. Nobody is able to make any proper predictions of these. It's pretty tough and difficult. So I think India is a good place to do a lot of research on climate. And if you are smart and if you are able to reach somewhere, then it is good to join in an organization. I feel there are good opportunities.
Okay. And so that, I guess, means that one of the things we are realizing is, before they used to think an MBA, an engineering degree, a medicine degree are the only ways to move forward. I think there's a lot to do in this space which they can actually use these.
Correct. In fact, space is possibly one of the best areas where climate change related activities can be done very effectively, because you look at the Earth from a big area, from a height, and you are able to get that synoptic view. That synoptic view helps you in understanding
so many things.
so many things,
Yes.
and that will give you an edge over anybody else, especially when you are trying to do climate change. And that should be a good area for the future.
Exactly, and especially, so that's why if I go back to my Star Trek watching days, it is really space
Yes.
the final frontier.
Yes, really.
Yes.
I agree with you.
Yeah.
I always agree with you on that.
Anyway, it was such a pleasure to speak to you after, I think, this 31 years
Yes.
older journey
Yes.
into remote sensing.
So
And
nice.
yeah, so
Yes.
wonderful to catch up. And I think a lot of young people today will be listening to this talk and the lecture as well, and
Yeah.
learning from this. So thank you very much.
Thank you. Thank you, Harini. Thank you very much.